So here we're going to look at harder questions involving speed, density, perhaps pressure, any relationship of the form which can be put into one of these blue triangles. Now, I hope you've watched the tutorial on the easier questions because in fact these key points here are the same. Harder questions, however, might involve using the formula more than once, but the principles, as I say, are the same. So we're going to dive straight in with the questions. So the first question, we've got John driving 25 miles at an average speed of 50 miles per hour, 40 miles at an average speed of 64 miles an hour, and we're asked what his average speed for the whole journey is. So clearly a speed, distance, time problem. Now, one of the criticisms of blue triangles is that you have to remember the formula. Well, actually, you don't, because as it says in the key points, we can use the units in the question to write down the formula. And the units in the question are miles per hour. In other words, miles over hours. And of course, speed is therefore miles is distance over hours, which is time. So even if you can't remember the formula, the question usually gives it to you. And that allows us to write down a formula triangle or a blue triangle. And here's one. Speed is distance over time. Notice how you put them in like that. Speed is distance over time. Right, now normal exam technique stuff next. Let's write down what we know and what we want to know. Well, there are essentially three parts to this journey, or three parts to the question. Part A is the first 25 miles. I've called it Part A. I'm going to call the second 40 miles Part B, and then we'll refer to the whole journey as W. So for each of those, let's write down what we know and what we want to know. So for A, we know that the distance is 25. We know that the speed is 50, but we don't know the time. For Part B, we know that the distance is 40. We know that the speed is 64, and again, we don't know the time. And for the whole journey, we know that the distance is, well, we haven't been given it, but it's 25 plus 40, isn't it? So that's 65. We don't know the speed, and in fact, we don't know the time. So we don't know much about that one. But the question is asking us to find the average speed for the whole journey, for W. So that is what we're working towards. And clearly, if we're going to find the speed, we need to know the distance, which we do, and the time, which we don't. But of course, we can find the time for the other two, for A and B, and if we add those together, we will get the time for the whole journey. So let's do that. Let's work with A and B first. So, working with A and B, let's use my blue triangle to rearrange the formula. We're trying to find the time, and so it very clearly, very easily says time is distance over speed. So let's write that down. Time is distance over speed. And for the first part of the journey, part A, the time is 25 over 50, which is 0.5, or if you like, half an hour. And for part B, the time is the distance, which is 40 over 64, and that is, in fact, 0.625, or 5/8 of an hour, but 0.625. Right, that gives us the time for the whole journey, but just by adding 0.5 and 0.625 together. But we don't need to add them together yet. Let's do it in a minute. Right, we're back to, for the whole journey now. Step 4, use the blue triangle to rearrange the formula. Well, we're back to speed equals distance over time. So I don't really need to use the triangle because that's already written down. And let's now put in the values we've got. The distance is 65 and the time is, well, I'm going to leave it as 0.5 plus 0.625. And if I stick all of that into my calculator, I get 57.8 miles per hour. And that is how you do that. Right, let's look at another question on a different topic, but with the same principles. Here we're talking about, if we read the question, density. Okay, and we're given the density of copper, which is 8.94. We're given the density of zinc, which is 7.13 in the appropriate units. And we're going to mix 70 grams of copper, 30 grams of zinc, which will give us 100 grams of the alloy brass. And we're asked what the density of brass is. So let's follow the steps. First thing we're going to do is write down the density formula. Now, if you can't remember it, don't worry. Density is grams over cubic centimetres. So again, as we did before, grams over cubic centimetres is, well, grams is mass and cubic centimetres is volume. So we've been able to write down the formula from the information in the question. And having written down that formula, we can now draw our blue triangle. Here it is. Okay, and we just go straight for density is mass over volume. There it is again, density, mass over volume. Right, now, again, we're going to write down what we know, what we want to know. And this time we're going to do it for copper, zinc, and brass. Now they've got obvious abbreviations. So for copper, we know the density is 8.94. We know that the mass is 70. And what's the other thing? The volume, well, we don't know that. For zinc, we know that the density is 7.13. We know that the mass is 30 grams. And again, we don't know the volume. And for the alloy known as brass, we don't know the density. In fact, that's what we're trying to find out. We know that the mass is going to be 100 grams. They tell us that, although of course it's the 70 plus the 30. And we don't know the volume. So it's the density that we're trying to find. What will the density of brass be? And in order to find that, we need to know the mass of brass and the volume of the brass. Okay, and in order to find the volume of the brass, well, what are we going to do? We're going to find the other two volumes and add them together. So let's work with copper and zinc to start with. So copper and zinc. We need to find the volumes of those, so let's use our triangle. Volume is mass over density. So let's write that down straight from my blue triangle. Volume is mass over density. And so for copper, the volume is 70 over 8.94, which on my calculator, if I do it on my calculator, I get 7.82. Well, I'm going to give it a few decimal places because I'm going to use those again in a minute. So 7.82998. For the zinc, I see that the volume is, again, mass over density. So this is 30 over 7.13. And 30 over 7.13 comes out to be 4.20757 something. That's probably enough accuracy though. And how do I find the volume of the brass? Well, I'm simply going to add these two things together, which I'll do in a minute in my formula. So now we're going to work with brass, and we're asked to find the density. Well, I've already written down the density formula, although I could use the blue triangle again. I can just write down that density is mass over volume, and for the brass, that's 100 over the two volumes we've just found, 7.82998 plus 4.20757. And if I stick that into my calculator, I get a density of the brass of 8.31 grams per cubic centimetre. And I've given that to two decimal places because that's what was given in the question. And so that might well be appropriate. So I hope that's helped do these more difficult questions.